You broke down everything, the whole stack, and the only thing that was remaining was economic security from a base chain. And that's the core concept of shared security, that, hey, you can experiment on all levels, be it the consensus layer, execution layer, and application layer, and that's what AVS is. At Catalysis, we are building an abstraction layer for shared security protocols to make it easier for AVSs or actively validated services to scale and thrive and get economic security from multiple restaking protocols. This was the most detailed discussion that I had in a long time.
I'm here with Abhishek Kumar. He's co-founder at Catalysis. Catalysis is an abstraction layer for shared security protocols. Basically, it allows AVSs to utilize many different restaking protocols for the security, effectively creating, well, an abstraction layer between AVSs and restaking protocols. We're going to get into all of that here, understanding how it works, why it's necessary, and what are the benefits for AVSs. Abhishek, thanks for joining me.
Thank you so much, Sebastian, for inviting me to this discussion. I'm really excited to share what we are building, and it's always been amazing talking to you, and hope to have a nice conversation here. Thank you so much.
Yeah, well, I'm really looking forward to getting into sort of the depths of Catalysis, understanding why it's useful. But first, maybe like looking at the AVS landscape and also the restaking landscape. Can you kind of give us an overview of what that looks like today and how it's changed over the last year? Eigenlayer obviously went mainnet this year. A lot of other restaking protocols like Symbiotic, Carrick, and also in the Bitcoin space have been coming online. So what's your view of the arc of restaking over the last year?
Yeah, amazing. I think that's a fantastic point to start the conversation with, right? What's the restaking market look like today and 6 months back or 12 months back, right? I would start by saying that, we are still in the early innings of the entire, restaking and shared security market. 6 months back, there were just Eigenlayer, and Eigenlayer launches mainnet, and there are also the other restaking protocols like Symbiotic, Carrick, that followed suit. And there are other restaking protocols on Babylon side like Satlayer, Pell, and on the Solana side we have Cheeto and everyone. So all these restaking protocols are coming up with new features, and they're going to launch. So definitely we see today that there are more than 10 restaking protocols across different chains, be it Ethereum, Solana, Babylon, and TIA. So Milky Way is also launching with the TIA restaking. So that's another one. And my thesis is that we will have restaking protocols on all chains in the coming future. So that's definitely on the restaking protocol side. As for the AVSs, there's had been huge demand or changes in how people have built AVSs and the number of AVSs that are coming up, right? So I think a couple of months back, we just used to talk about Lagrange or Predicate and e-Oracle and a couple of these AVSs today. But now that kind of ecosystem map of AVSs has increased, right? So we now have 20-25 AVSs live on Eigenlayer, and a couple of new AVSs that are being launched with Symbiotic, and Carrick has its own ecosystem partners and so on. So definitely I see that there's hundreds of AVSs that are still in development. We have talked to a majority of them. I know yesterday Nader from Eigenlayer, tweeted that there's he's tracking, or the team is tracking at least 600 AVS that are in development, which is a huge number, I would say. So we released a blog post a couple of weeks back about our vision of 1,000 AVSs, and I thought it'd be 12 months since we'll have that vision will be reached, but it seems like it's much sooner. So definitely there's a lot of changes in the AVS space, and particularly because the process of building AVSs has become much more simpler with Catalysis. When trying to make it much more simpler with their other companies or projects trying to do the same, essentially making the entire process of onboarding and building AVS much smoother and simpler and faster. And that has, I think, created a lot of demand, and kind of a lot of people and teams are really understanding what shared security is and what the implications are, and are they looking to build AVSs. So yeah, I'm really bullish on the stages so far. 6 months back, 25 AVSs. Today we have like 100 AVSs, and still counting. So the next year is going to be the AVS year from my perspective.
Maybe just taking a step back here so people understand like the different ways that we can build applications. So obviously there's the app chain route, which is, go out and build your own app chain, get a validator set, have sovereignty over your entire stack. And then on the other end of that, I guess there would be, building a roll up, right? Or a layer two, that depends on the security of Ethereum or some underlying chain. Where does an AVS sit on the sovereignty spectrum, with regards to these two opposing ways of building an application?
Yeah, that's a good question. So I think there's definitely one thing about building an app chain or like application specific chain or like a separate L1, or you can build the same application, or we call the restake rollup concept, which is you're building a rollup that inherits or like doesn't inherit like complete security from Ethereum, but also that reuses some validators from Ethereum set, and kind of use restaking for that. Both approaches are great, but it's just about the ease of decentralization and the ease of like building something, which restaking makes it much easier. I think your question is about sovereignty. To that, I think definitely app chains are more sovereign in the sense that they own their own network dynamics, and things like that. But it's essentially harder to bootstrap. Like that's the trade-off like we're making. We're trading sovereignty with the time to go to market, right? In terms of like using like building a roll up or L2 using shared security, or using while the process of restaking makes you less dependent on your sovereignty. So you actually lose a little bit of sovereignty to faster go to market. So you can decentralize better, bootstrap faster, get the customers in, make the transaction happen, and then you can do whatever you want later. So definitely on that front, there's a trade-off between kind of scalability, decentralization, time to market, and the sovereignty part. So which is something it really depends on the teams that are building those applications. Some teams might really want sovereignty, so they would probably want to choose like, hey, we'll build an app chain, or we'll have our own chain, and things like that. But again, that makes it harder for you. You can go that route if that makes sense for a business, or you just build a restake rollup using something like Catalysis and in much less time, and then you can go to market faster. So that would be my view on that.
Yeah, there was this great diagram that I saw in one of your blog posts, and actually I saw this diagram in one of Sriram's talks, I believe in like Salt Lake or something, a couple of months back, and it basically has like Bitcoin, Ethereum, rollups, and eigenlayer. And with Bitcoin, you have the sort of security, consensus, execution, application all in one stack, and then Ethereum allows you to have multiple applications on top of a monolithic execution, consensus, and security layer. And then if you go the next in the next pane, you have rollups where you have multiple applications and then multiple execution layers on the same consensus and security. And then restaking, or in this case eigenlayer, but restaking broadly, allows you to have multiple applications built upon multiple execution layers that may use different consensus mechanisms on the same shared security. And I thought this was such a great, people should go to this blog post. I'll link to it in the show notes. This is such a great way to see that progress from very monolithic sort of Bitcoin, one single stack, one application, all the way down to security to, eigenlayer, where one single security source can secure multiple consensus engines, algorithms, systems, which themselves bring consensus to execution environments, which themselves execute application state. So That's really, I think, a really great way to think about restaking. And I wonder, so where does Catalysis sit in that stack?
Yeah, you bring a perfectly beautiful point here, right? I would recommend all our audience to really watch that talk by Sriram. I think it was the Stanford Blockchain Conference 2024. That talk where he talks about like strong cryptoeconomic security for like arbitrary validation tasks. So yeah, I think to give some more context on what that really means, building on what you said, Seb, is that Bitcoin, there of Bitcoin, let's say any kind of like blockchain or decentralized consensus engines could be divided into in four different stacks, right? The first is the application layer, right? That's consumer facing, where applications with different kind of features could be built, and then that applications actually run on the execution layer. So that's the second layer from the top, that executes, that kind of provides the environment for application to run on. And then we have the consensus mechanism, that's like core part of decentralized systems, where like this execution is kind of verified with like consensus among different nodes. And then finally, the security is inherited from a base layer. And for that, let's say that's the Bitcoin. So we have the four layers: application, execution, consensus, security. In Bitcoin, we have like this monolithic kind of design. In Ethereum, what we had was, we broke down the first part. That is, we have like you could have programmability, so you could have build multiple types of applications on the execution layer, that is on the EVM, right? So we had like smart contract innovation. People could build different kind of applications or smart contracts on that execution layer, and then consensus and security. That was like Ethereum stack. Now coming to rollups or L2s, what we did was, you can build multiple applications. We broke down the application layer. We also broke down the execution layer. Like we have like different kind of, you can experiment with different kind of VMs. You could have any kind of VM that you want, and you can experiment that. So it's like application specific rollups and a bunch of rollups that you have. But still, we didn't tinker with the consensus layer. This is third layer, and that's where the shared security came into picture, right? Shared security mean that, hey, you know what? You can build any kind of applications that's enabled by Ethereum. You can experiment with the execution layers, because that's what rollups provide. But now we can also experiment with different consensus mechanisms. So it's like you broke down everything, the whole stack, and the only thing that was remaining was economic security from a base chain. And that's the core concept of shared security, that, hey, you can experiment on all levels, be it the consensus layer, execution layer, and application layer. And that's what AVS is. Like, an AVS is, as a decentralized service or system that allows you to configure execution, consensus, and application all at the same time. It's like the most modular, in the sense, the most powerful thing that we have seen so far. And all of this secured by the base layer. Now, where Catalysis comes in picture is that we enable, we enable teams to build AVSs, and not just on Eigen layer, but also other restaking protocols. So as you mentioned, as I mentioned, there's different kinds of innovations, all these different stacks, like application, execution, consensus. What we enable to do is that we enable you to do the experimentation by providing the necessary infrastructure tooling that allows you to do that. You want different consensus algorithms, you can use Catalysis, the Catalysis SDK that we're providing. Like, it has all those modules for configuring execution environments, configuring consensus algorithms, and all those things. So whatever that's possible to do with shared security, you can do with Catalysis, and that's what we're enabling.
All right. Well, it's a good segue into Catalysis. So can you talk more about like the platform, the architecture, and we'll get into like how developers use Catalysis to build their AVSs, leveraging different sources of security.
Awesome. Yeah. So yeah, before proceeding to answer this question, I just talk about Catalysis and what we're building. So at Catalysis, we are building an abstraction layer for shared security protocols to make it easier for AVSs, or actively validated services, to scale and thrive and get economic security from multiple restaking protocols. We are trying to abstract the entire complexities of restaking, and trying to be an abstraction so that you don't have to really think about the infrastructure that is in restaking protocols, and it's just it's for you, it's just about getting your own security and just decentralizing your service. So that's what we're building. In terms of the stack, we sit between the AVSs and the restaking protocols. So in order to understand what we're building and how that really makes sense, imagine if you're like trying to build an AVS, right? Now you can spend like weeks and months, trying to understand like different architecture differences and different like ecosystem differences from eigenlayer, symbiotic, karak, and the GDO and then Babylon and so on. And you can try to understand like what architecture makes sense for us and whatnot. So that could be something that you could do. It would definitely do, but it would take a lot of time for you to do that. Like instead of building that AVS, we're spending time researching on that, and we don't expect everyone to become an expert in restaking or shared security, right? So that's where we're trying to come in. We say that, hey, you know what? We would provide the necessary abstraction for you to work with shared security, and as part of that, the abstraction layer is nothing but the smart contract layer that enables interoperability between different restaking protocols across different chains. So, you could have that orchestration layer connects like Ethereum restaking protocols, like eigenlayer, symbiotic, karak. It connects the Solana restaking protocols like GDO, Solar, and so on. And on the Babylon side, connects like Sattler and Pell and so on. And all this rewards distribution and slashings are like managed by Catalysis layer. In terms of how devs use Catalysis, so we're providing Catalyst SDK, which in the most easiest sense, it could be thought of as like Cosmos SDK for building AVSs, right? So as like Cosmos SDK provide like modular tooling for you to configure different kind of consensus algorithms, and things like that to build app-specific rollups or app chains. What we are providing for the Catalyst SDK lets you configure anything from rewards distribution, node operator selection, slashings, and all kinds of things that you need in order to configure, manage, and build AVSs. And one of the things is you can configure how much economic security that you need from any of the restaking protocols, right? Which is one of the cool features that we provide. So say, you want $100 million economic security. Say, for example, you need $100 million of economic security for AVS, and you can configure via our SDK, we have a module that you can say that, hey, we want, let's say 50 million from eigenlayer, 30 million from Symbiotic, and 20 million from Sattler, things like that. So you can configure all these things, you can dynamically rebalance them, and the goal would be to, optimize for what you pay for renting this economic security, so that you have the most cost-effective security and also have the most robust AVS on your side. So that's kind of how the Catalysis stack looks like and how developers would try to use and want to use on the platform.
Interesting. So one thing that kind of comes to mind here is that, that because you talked about the Cosmos SDK, the Cosmos SDK can be used in a restaking configuration in the form of interchain security or replicated security. I forget what they're calling it now. Why couldn't one use like an existing SDK like Cosmos or even the OP stack to plug into like different restaking protocols? Like, if you want to use, say, Cosmos SDK because you like that development framework or whatever, like, couldn't you have just sort of some kind of an adapter that sits between whatever application SDK you like and the kind of like restaking ecosystem? Or is there something unique about Catalysis that where you need to own the entire development stack in order to have this work?
Yes, so some of the teams that we talked to try to use Cosmos SDK for the use for the use case, but they mentioned that they had to change a lot of the code, and they ended up changing a lot. So, and that really makes sense, right? Like Cosmos SDK was not built to serve the unique use cases of AVSs. Because as we talked earlier, right, like rollups don't let you configure the consensus, don't allow you to configure a lot of consensus algorithms and break that down. So definitely it it has some components and models that can be reused for AVS. Is like, you could probably use, if your AVS uses like consensus mechanics, you get like we have your tendermint from Cosmos SDK, that's perfectly okay. But now there are like specific use cases that I mentioned, like reward slashing, and especially what we are doing about interoperability between different restaking protocols and cross chain, which is something unique, very, very unique, and has to be implemented on our end. So being said that, Catalyst SDK, using Catalyst SDK would feel like using Cosmos SDK, I would say, because we want to be providing that kind of developer experience, because we know that Cosmos SDK has been a successful one. People like it, the way it's organized and presented. So we want to provide like a nice UX experience like that, like DevX experience. But as I mentioned, we have to build a couple of these new components together, and which frankly needs an entire new code base rather than just forking Cosmos SDK to suit the use cases of AVSs. So yeah, that's how I think about it.
Right. Okay. Interesting. And like, so when using the SDK, what language are developers building on? I mean, is it sort of Solidity, or have you built your own language, or using something else?
So it's Go based. So the Catalyst SDK is currently in Go, so Golang, and it would be, we are trying to add support for Rust, but I think the most of teams that we talk to have their like development stack in Go, and that's where the core focus is, building in Go.
Why is that when like a lot of, sort of up and coming blockchain, like all VMs, I guess, like whether it's, Solana or CosmWasm or even Move are Rust based. What's the kind of design decision behind using Go?
Yeah, I think it's the decision to use Go came from having the customer research and in talking with different AVSs, and trying to understand like what was the most preferred language that they have. So one of the questions that we already asked with all of the AVS is like, what's the tech stack that you have? What kind of programming language do you use? And 90% for our research came out, it's Go. I know it's and I think statistically speaking as well, like Go is the most preferred language, especially the Ethereum ecosystem, I would say, and also the Cosmos ecosystem. But yeah, I'm cause if I give an example, right, like Get, which is like the Go Ethereum code base, one of the highly renowned, it's in Go. We have this Cosmos SDK in Go. There are a couple of different cryptographic packages that are like highly used that are in Go. So I think the blockchain ecosystem has seen a lot of this, dependencies that have already built in Go. So people just make it. It just makes it easier to just import all those open source packages, and then just build their stuff. But yes, having said that, I definitely think that there's like growing interest in the blockchain ecosystem to use Rust, especially because it provides like more memory safety, and so it makes it more robust against crashes and stuff. Um, but also, I think it's that adoption is picking up, and once we have that, we definitely add support. But once we have Go and Rust support, I think that would cover 99% of the cases.
Okay, this might be a sort of simplistic question, but uh, is Rust better adapted for smart contracts and Go better adapted for building your own chain? Um, is that like a good distinction to make, I guess, between both languages?
There are a couple of trade-offs that teams have before choosing those, any of those Go or Rust. Yeah, I would say that Rust is definitely more memory safe in the sense that those problems that can occur in production is already taken care of, so you actually run into less problems in production, right? So that makes it just more safe against things that like memory leak and stuff that could never happen, or like that could, it's very rare to happen, and hence they're better suited for like probably smart contract development, but just like Solidity is the most one. Um, and from my experience, we have seen Go being used in distributed systems a lot. Like when you are programming like distributed systems, and you like more concurrency and stuff, Go makes it much easier to build all those, you know, complex systems with ease because it's easy to understand, easy to write and stuff. And I think that's why my distinction would be Go would be used for like high performance distributed systems, and Rust would definitely be used for the same cases, but where like safety is critical. Like you cannot have a bug that messes you up in production and in execution. So yeah, that would be my like rough things. But there are teams that are more capable to answer these questions, and the different trade-offs there.
Cool. So one of the things that Catalysis offers AVSs is diversified security. So you can derive security from multiple restaking protocols. You talked about Eigenlayer, Karak, Symbiotic, Babylon, Milky Way, and I think there's one on Solana I'm not super familiar with. But what benefits do AVSs gain from utilizing multiple security sources? And I'm talking about like real tangible benefits, not this kind of like, hypothetical kind of like maybe some slashing, but is like, as we have very sort of professional validator sets, slashing is like probably highly unlikely, except in some edge cases. But like, are there real tangible benefits that AVSs will benefit from by having just a very diversified restaking security set?
Yeah, absolutely. There are couple of really important points that AVSs should note, and they are and that's why they should use or choose to use Catalysis and try it out. And like, let me go through a couple of these. So I think the first thing to understand is that economic security that is not free, right? That economic security that you are renting from the Eigenlayer or like Symbiotic or Babylon or Milky Way, any of the using platforms has a price that you have to pay in terms of rewards, right? That's the AVS rewards you have to pay to those protocols, and that to compensate the node operators and whatnot. So in that case, I believe, and we strongly believe, that there is going to be competitive dynamics across the pricing that is present across these racing protocols, right? For example, probably like as an AVS, you might have to like pay 5% in AVS rewards to Eigenlayer, right? And let's say for the same thing, you might be paying like 2.5% on SAT layer that's backed by Bitcoin or Babylon, right? This is like rough numbers, or like this is like very random numbers, but the thing that I want to stress on is that there's definitely going to be competitive pricing across the different racing protocols. As an AVS, you would want to get the best out of it. You would want the most cost-effective security because you want to reduce expenses and pay only the amount that you need, and that would mean that you should have like a global price discovery mechanism. And that's what Catalysis provides. That's one. Like it enables a global price discovery by aggregating all this economic security from restaking protocols. So you have like a single bird's eye view or like unified interface to see like how much to pay for what, and you can kind of diversify like you do for a portfolio. Like you want to put in that and you get that much amount, so you have to spend on that and so on and so forth. So you can do that. The second point is more on from the security standpoint, right? Which means that building on Catalysis actually hedges or distributes a risk that comes from things like cascading slashings or mass LRT migrations. What I mean by that is, like, let me give you a concrete example, right? So for example, you are building an AVS on, say, X platform. It will be better if I don't name names. Otherwise, that'd be like not a good thing. So let's say you are building an AVS on X platform, and that AVS needs $100 for economic security. But now, let's say there's like cascading slashes, massive cascading slashes that happen, and then all of this economic security is reduced, and the platform doesn't have $100 of economic security to provide for AVS. Now, that means that your AVS is insecure, right? And it's vulnerable, and it can be hacked and whatnot, and any kind of malicious things can happen. So once you build on Catalysis, uh, your risk is distributed across this multiple restaking protocols. So even if one protocol has some issue when like they have slashing and cascading slashings or like failures, and like a lot of restake LRTs like put away restake capital from the platform, your AVS is still secure, right? because now other restaking protocols are unaffected by what's happening on one platform. So that distributes the risk.
Sorry to interrupt. What could
Yeah.
cause like cascading flashes?
Yeah. So cascading slashings are enabled when one operator is validating for multiple AVSs. Let's say an operator is validating for 5 AVSs, and one slashing could trigger another slashing because the same operator is validating for the other AVSs. And if once that happens, then the second AVS gets slashed, and then the third, and so on. And that is actually connected with the other operator, which might be validating for the same AVS. So like AVS 1 is valid by operator 1 and operator 2. So that if that AVS 1 gets slashed from operator 1, then operator 2 also gets that effect, hits, takes a hit, and then so on and so forth. So you can imagine all those things happening, and then one thing leads to the other, and then you ended up with like lots of slashings. So actually there's a great research piece by the Gauntlet team on this, where Tarun Chitra and Tarun Chitra and Malish Pai, and they all, on those researchers actually posted something about how LRTs could solve this problem by rebalancing when to solve this cascading slashings problem.
Okay. I mean, how likely is this to happen though? I mean, like in a world where, you have highly professional validator service, industry, like the coarse ones and the kilns and of the world, running, staking infrastructure for restaking protocols and AVSs, as a result, like, have we seen slashing events already or how likely are those to happen?
Yeah, I think this is definitely a research in progress, I would say, because we do not have slashings live on any racing platform. So so it's just not enabled, so you don't have that. But it's the biggest point where you need to know what things would be enabled once you enable, what things could happen if you enable slashings. And that's where this research comes in picture, right? It's not the thing that, hey, we can enable slashing, because Eigenlayer could have enabled slashings probably months back. But I think that's what the team is working on, to understand the security implications of that. And that's where things like that could happen. And people are, and of course, I think Eigenlayer solved this problem by having this concept of unique stake and slashable stake that really mitigates all these effects when like one operator has a unique stake delegated to one AVS. So even that slashing happens, the other AVSs or other operators are not affected. So yeah, as I say, these things are still things that could happen in security research, but of course, I think, as you mentioned, there are some professional institutional gate node operators that are operating these AVSs like Chorus One, Luca Nodes A41, Peer 2, and it seems unlikely that this could happen. But of course, in a decentralized setting, you cannot be sure, right? And that's how you have to make a system so secure that even parties could collude to do something malicious, they are not able to do that, or like they get nothing out of that.
Right, right. Interesting. So, what else do AVSs have to gain from diversified security, except for the security part? Like on the liquidity side, what are the benefits of having multiple restaking protocols backing your AVS?
Yeah, I think so the first that I mentioned is it enables global bias discovery. The second one is that it enables you to build robust AVSs. And so third is that now you have a single unified interface to kind of tap into multiple pools of security. So it's like your market for getting enormous security is now expanded. It's not limited to one. It's limited to it's expanded to tens of different markets. So, and you can have that one way to get that security. So that's one. From the liquidity side, I would say if you're building an AVS on Catalysis, all of these different LRTs could provide economic security to your AVS, or delegate that kind of liquidity to your AVS via these different restaking protocols. So you're not limited to like getting Renzo or say EtherFi or like Kelp DAO security via Eigenlayer anymore. Your AVS, by virtue of being on Catalysis, LRTs like Melo or like EtherFi could provide the economic security via both Eigenlayer and Symbiotic and so on. So it's like you have an option or like way to get more and more security, and also like on different diversified settings, and also makes it easier for LRTs to do so as well, right? So yeah, building on top of that, so one of the things that we enable via abstraction layer is called on-chain auction mechanisms. So we're building like a marketplace, you know, on top of this Catalysis abstraction layer that kind of connects LRPs to AVSs. So what I mean by that is that as an AVS, if you're coming to Catalysis and saying that, hey, I want $100 of economic security, I don't care. I don't really care if it comes from Eigenlayer or Symbiotic or Jito or Milky Way or any of the racing protocol. I just want $100 of economic security, right? Now, what this platform, what is like auction on-chain auction market could look like is that LRTs across these different racing protocols with the diversified portfolios could bid for this AVS that, hey, I think this AVS is good, the team's good, and all of those things. We like this AVS, this could grow, and we want to bid for that. And they kind of place their bids on using the Catalysis platform, and then AVSs would have like more flexibility into choosing which LRTs to choose from, how much economics that they need. So it's like it puts back AVSs into power. Like they have like options to decide on their side, and LRTs also have like more flexibility in allocating capital across switching protocols via Catalysis. So that is something that we're trying to make it seamless, because in terms of building an AVS, dev tooling is one part. The second part is actually getting economic security or getting actual allocation from LRTs. That's one of the key problems that we're trying to solve as well at Catalysis. Yeah.
Have you guys heard of a protocol called Valence?
I'm not sure I heard the name before. Yeah.
Yeah, Valence is one of our portfolio companies. Max has been on the podcast before. They're creating essentially a marketplace for protocol-owned liquidity. So, think of it as like what Eigenlayer is to security, they are to liquidity. So it like you effectively create a marketplace where, protocols that want to deploy liquidity into different like AVSs, liquidity pools, etc., can do so in a kind of programmatic way. I think that maybe sort of like layering this on top or having Valence somehow like be a part of this would like allow this kind of automated free flow of liquidity between the restaking protocols that like want to choose with whom they want to deploy the liquidity, and like AVSs that have like a demand for liquidity and may want to um give up something like for that liquidity, like token allocations, etc. Yeah, maybe something to consider here.
No, absolutely. Yeah, I think that'd be great. I think in the end, look, it's just AVSs that they're on demand side that need some economic security, and this liquidity providers, LRTs, and as you mentioned, Valence could be, if you could have this integration with Catalysis, I think just make it simpler to connect supply and demand. So yeah.
Yeah. Utilizing Catalysis, does it introduce any unforeseen challenges with interoperability and liquidity fragmentation in the same way that, building on a different role, like two different rollups have that interoperability issue? Or is it sort of facilitated through the fact that there is a shared security layer?
Yeah, I think good question. Using Catalysis definitely makes it lot simpler to build an AVS and like kind of decentralize the service and just go away, just move on with it. But there are some challenges on our front to kind of really build an abstraction layer out. Like one of the key challenges that we have is to really make sure that we are able to integrate all these different diversified architectures that these restringing protocols have. That's one of the interesting challenges that we have, and we have an answer to that. And that's the second challenge is definitely to enable that, to enable interoperability between cross-chain restaking, right? Say you have Eigenlayer on Ethereum and you have Cheeto on Solana, and then this rewards that an AVS issues has to be distributed across Solana, across Cheeto and Eigenlayer, and that's where the interoperability in cross-chain messaging happens, and that's one of the things that we make sure that nothing goes wrong there, because it's actually sending out money and rewards across the different chains. So that's one of the challenges that we need to think about, because we want it to be both secure, that is, it should be robust when we are sending rewards across different chains, so that in lost away or like nothing wrong happens. um yeah, so that'll be my thing. And it just, there's no there's no additional security considerations that come into picture. So I think these are like two important things that I can think of. The other question that you mentioned about liquidity fragmentation, um, that doesn't really happen. We are trying to solve that part. Like we are aggregating this, kind of not liquidity but economic security fragmentation that's happening by, by the virtue of having like Icon Layer having $10 billion security, Symbiotic having 2.5, Babylon 2.5, Milky Way having like 300 million, and so on. So there's definitely a growing fragmentation of economic security, and that we are not, we are actually trying to solve that by saying that, hey, let's not really fragment, keep on fragmenting this ecosystem and make it just simpler to use, and get economic security. So yeah, that would be my thing. From just to summarize my answer, from an AVS builder perspective, you have nothing to worry about, because all of these challenges are on Catalysis side, and we are trying to, we are what we're trying to do is to provide an interface so you don't have to worry about it, and you are just abstracted from the complexities of that. But it's definitely one of the things that we need to, take care of and make sure that nothing goes wrong, and you give like the best developer experience possible in building your AVS.
So one of the things that we've talked about is catalysis markets and how like catalysis creates this opportunity for new marketplaces to live on top of your architecture. So we've discussed this privately about like these auction markets, bribing markets, arbitrage markets, and yield bond markets. Um, can you describe like what those are and like how these emerge from this product that you're building?
Yeah, absolutely. I think this is the markets part is one of the core innovation or kind of interesting pieces that Catalysis as an abstraction layer brings to the table, right? So as you mentioned, Seb, so there are like a couple of different markets that we have identified that could be built. Like, they could be like bribing markets or arbitrage markets, auction markets, and yield bond markets. I could probably give a small short intro for like introduction for all of these different kinds. Before that, let's try to understand like why Catalysis is the way forward, and what is that makes Catalysis feasible for these markets to happen, right? What's that? And then the reason why that's possible is because Catalysis sits like as an aggregation layer between all the AVSs and the restaking protocols. So as like a middleware, um, as a middleware layer, we have we connect AVSs to, to the switching protocols and vice versa. We kind of enable all these different restakers, like, stakeholders in the restaking ecosystem to talk to each other and kind of facilitate all these deals. Now, let me give you one example of how that looks like. As prior to this, I was talking about on-chain auction markets, if you remember, right? Um, and that is what we call the auction markets. And this is the market that connects AVSs and LRTs. So it disconnects LRTs to delegate economic security efficiently to AVSs. So that's like the on-chain auction markets. And that's feasible because we connect, like we have all the AVSs on our side. So it makes it easy, like one way for LRT to see what AVSs are there and just delegate to it. Right? It's like makes it much, much easier for them. That's the value prop from the on-chain auction markets. Now there's like a bribing market, for the lack of a better name, we call it the bribing market. But definitely the interesting, the idea is that, as I mentioned prior to this as well, like there's definitely going to be competitive dynamics across these different restaking protocols, right? Because everyone would want to have more demand for the economic security, so they would attract more and more AVSs to our side. Now, what that could result is they could provide more incentives. So restaking protocols could provide more incentives to AVSs and say that, hey, this is what you get if you want to build on top of us, right? And we want to make that process more on-chain and transparent, and saying that, hey, you can you can, if you want to attract an AVS, these are the incentives that you provide, and AVSs could like choose and kind of say that, hey, yeah, for this economic security and this kind of incentives, I would choose that much of economic security for my layer. For this and that, I would choose like symbiotic and so on. So you have like complete power of what you want to decide, right? That's the bribing market, or like incentive market that connects AVSs and restaking protocols. It makes it much more simpler for a deal to happen. Like there's arbitrage markets, that's really happens in a restake capital pools from from an LRT perspective. If you're moving capital from one listing platform and delegating, let's say you're moving from eigenlayer to symbiotic and so on. So there's like a couple of arbitrage opportunities that might come in that you can leverage via Catalysis. And the last is, so we're working with partner Pi Finance, Eric. I don't know if you know him, but he's a good guy. And what they're building is like that allows you to tokenize future yields. And they're probably live on Solana. They're going to live in Solana. But yeah, one of the things that we discussed with them is that, hey, you know what? You can also do a tokenized future yields of AVSs via Catalysis. What that would mean is, when these AVSs, they don't have to release rewards right now, but in terms of having a future yield, you can tokenize via our platform, and that could be distributed back to restakers. To summarize, we have these different markets that are only possible by virtue of being an aggregator on the AVS side, and that enables like very interesting, unique interactions to happen between different stakeholders in the restaking stack, including like restaking protocols, LRTs, and a couple of others, and that interesting creates a lot of different markets. And we believe that once we launch, there could be different kind of markets that people would imagine and would build, and hopefully Catalysis would provide like a bedrock and a bootstrap phase for that to execute and happen.
What's the roadmap here, and what's planned in the next couple of months for Catalysis?
Yeah, the roadmap is that we are going to launch our first DevNet in a few weeks. So it's scheduled to happen in the second week of January next year. We are taking some time to test and stuff. So that's kind of first DevNet that would enable teams to use Catalysis for the first time and see what you can do really by having the power to get economic security and configure them and manage across like Eigel and Symbiotic for us. So for DevNet, we'll be supporting all the Eigel and Symbiotic. But our plan is, the next year plan is to be live on Ethereum mainnet for Eigenlayer and add support for Eigel and Symbiotic. So we want to do that by Q1. In Q2, we want to also integrate with SatLayer and Pell, preferably SatLayer on the Babylon side. So we can provide this feature for AVSs to also get tap into the the ecosystem effects of the Babylon ecosystem, and we want to do that and complete by Q2. And that's kind of the current roadmap looks like, and we are like we're working really, really hard towards that. And hopefully we want to unleash the power of what we're building and really show what our vision really looks like for our audience and devs and whoever's listening to this podcast.
Cool. Is there anything we missed? I think we covered pretty much all of it, right? Unless I'm missing something.
No, Seb, I think this was the most detailed discussion that I had in a long time. So I think we missed. I think we didn't miss anything.
Well, definitely, we'll have to have you back on as new things emerge, and as Catalysis goes live, and you have AVSs building there. So happy to have you back on again at some point. But until then, thanks so much for coming on, and hope you have a good holiday season.
Thanks, Seb. Thank you for having me, and for our audience, please be tuned. Follow our Twitter. It's called Catalysis. I can, probably we can share that.
That's in the show notes. Absolutely. Yeah.
Absolutely. Thanks, Seb. Thanks for having me, and great discussion and bullish shared security.
Thanks. Cheers.
Thank you so much. Bye bye.